All right, let's jump right in. Welcome to this explainer. Today we're going to break down how physicists are actually working to bypass the ultimate speed limit of the entire universe. We're totally skipping past the science fiction here, and we're looking directly at the actual equations and the hardcore physics being developed right now to warp space itself.
25 trillion. Just let that sink in for a second. 25 trillion miles. That massive number is the distance to our absolute closest stellar neighbor, Proxima Centauri. When we talk about interstellar travel, you have to realize we are dealing with numbers so ridiculously large that they honestly completely stop meaning anything to human intuition.
And 70,000. That is the number of years it would take our absolute fastest probe, Voyager 1, to cross that immense distance using conventional physics. Just to put that into perspective for you, basically the entire recorded history of human civilization would fit inside just a tiny, tiny fraction of that trip.
Okay, let's move on to part 1, the insurmountable wall.
Now you might be wondering, why can't we just strap bigger engines onto a ship and literally force our way there? Well, it all comes down to a fundamental geometrical reality. Einstein's speed limit is the absolute law that nothing moving through space can outrun a beam of light. His equations actually prove that as a ship approaches light speed, its mass becomes infinite, which means, to go faster, you would need infinite energy. So it's not just a technological hurdle we can engineer our way out of, it's a structural wall built directly into the fabric of reality.
But wait, because that leads us to part 2, the space-time loophole.
Here's where things get really fascinating. The universe actually has a built-in loophole to Einstein's rule. As this quote perfectly summarizes, space itself was never part of the contract. See, Einstein's rule only applies to objects moving through space, but space itself doesn't have a speed limit. And we know for sure this is true because cosmologists observe the universe expanding, right? Distant galaxies are moving away from us faster than light. They aren't breaking the rules. The space between us and them is just stretching.
Which brings us to part 3, the Alcubierre warp bubble.
So, back in 1994, a physicist named Miguel Alcubierre decided to treat the warp drive not as some sci-fi trope, but as a rigorous homework problem using general relativity. And he discovered exactly how a warp bubble manipulates space-time geometry to enable faster-than-light travel. It works like this. On the leading edge of the ship, the space in front aggressively contracts. Then, on the trailing edge, space aggressively expands. Basically, the bubble is moving the space around the craft, while the ship just sits perfectly still inside it.
To really grasp how the ship itself carries absolutely zero kinetic energy, think about these simple analogies, where the environment is doing all the heavy lifting. It's kind of like a surfer riding a swell, where the wave does all the work, or a conveyor belt made of space, just moving right underneath you. But my absolute favorite analogy is this. It's like a raisin in a loaf of rising bread. When the dough expands, the raisin moves along with it, but the raisin itself hasn't exerted any energy whatsoever.
Because the ship acts exactly like that raisin in the rising bread, the astronauts inside would feel absolutely zero acceleration. None. Even while crossing massive interstellar distances. Inside that bubble, it's perfectly flat space. You could literally sit there sipping a cup of coffee without a single ripple in your mug, totally and completely isolated from the violent space-time geometry raging on the outside.
You can actually trace the rapid evolution of this theoretical physics, moving from an unbreakable speed limit straight into modern engineering. We go from Einstein's 1905 limit over to Alcubierre's 1994 metric, which was then optimized by Van den Broek in 1999, all the way up to a massive 2024 breakthrough by a private lab called Applied Physics. But before we dive into 2024, we kind of need to talk about why the original models hit a massive snag.
Enter part 4, the exotic matter catch.
So the huge problem with Alcubierre's original superluminal, or faster-than-light trick, is that it required a fuel that breaks our very understanding of reality. While ordinary matter has positive energy and bends space inward, creating the regular gravity we feel every day, his math demanded a massive shell of exotic matter, stuff with negative energy. It exerts anti-gravity, bending space outward. The catch? It's a substance nobody has ever observed in bulk anywhere in the universe.
And honestly, even if we could find that stuff, traveling faster than light creates some genuinely terrifying lethal hazards. Moving that fast generates an event horizon at the front of the bubble that completely cuts off communication. It also traps lethal quantum Hawking radiation that would literally cook the crew alive. And worst of all, the bubble violently sweeps up cosmic dust and hydrogen along the way, trapping it into this super concentrated energy beam that would just completely annihilate whatever destination you arrived at. No way around it.
Which brings us to a huge pivot. Part 5, a subliminal reality.
Because of all those insane lethal hazards, back in 2024, a private research team called Applied Physics asked a brilliant question. What if we just slow down? They mapped out an incredible solution, proving that a warp bubble could actually be constructed entirely out of ordinary positive energy matter that we know for a fact exists. It was a rigorous, constant velocity physical warp drive requiring absolutely zero exotic negative energy.
So the trade-off between the two models becomes super clear. The drive proposed in 2024 is subluminal, meaning it travels slower than light, but in exchange it completely eliminates the fatal radiation, the planet-destroying debris beam, and the need for impossible negative energy. It basically takes the warp drive out of mathematical fantasy and turns it into an actual, solvable engineering problem.
Now, you might be asking yourself, if it's slower than light, what's the point, right? Well, while it definitely won't cross the galaxy in a week, this subluminal warp effect means astronauts inside that flat space bubble could tolerate continuous, blistering acceleration speeds without being completely crushed. Traditional rockets would literally kill a crew at high constant acceleration. But a subluminal warp drive, it turns a grueling 6-month Mars trip into a smooth journey of just days.
Which leaves us with this final amazing thought. Perhaps the real value of the very first warp drive won't be reaching distant stars at all. Maybe it's just about safely and rapidly unlocking our very own solar system using physics we can finally start to engineer today. It's an absolute game changer for how we view the final frontier. Thanks for diving into this explainer with me, and I really hope it leaves you as fascinated by the math of the cosmos as I am.